Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Simple Electronics, and today I've got a very special guest, Scott Shawcroft. How are you?
I'm good. Thanks for having me.
Thanks for coming on. Really fortunate set of events brought you to the podcast, but I haven't actually heard much about you until you were recommended as a guest by a viewer in, I think it was...
Unexpected Makers?
Yeah, it was Unexpected Makers stream. So can you tell everyone a little bit about yourself?
Sure. My name is Scott Shawcroft. I go by Tan Newt online, which is weird and a story in and of itself. I currently have my own company called Chickadee Tech, but I contract for Adafruit Industries, which is an open source hardware and software company out of New York. I'm the lead for CircuitPython. CircuitPython is a version of Python designed for microcontrollers, little tiny computers that are really inexpensive. And our whole goal is to make it really easy for people to get into electronics.
We are going to test the validity of that claim once I get started. I actually finally have a couple of microcontrollers which are very well suited for micro and CircuitPython. But can we start from the very beginning? Now, there is MicroPython. There's Python, MicroPython, and CircuitPython. Can you give a little bit of an idea what's the difference between regular Python, CircuitPython, and MicroPython?
Right. So regular Python is by far the most common version. And kind of when talking about what version of Python you're talking about, you usually call it CPython. Because it is implemented in the C language. There is actually a version of Python that's implemented in Python too. So if you're talking about what implementation, the normal desktop Python is CPython. And I think its origins are in the 1990s. A guy called Guido van Rossum started it. And a lot of its syntax was based around a programming language he had worked on previously that was meant to make it easy to program. So one of the core tenets of Python, OG Python, is that it's really easy to use and really easy to get started with. So it's been growing in popularity since the 1990s. A lot of folks will find that they use it just to get some quick task done. There's a pretty famous book called Automate the Boring Stuff with Python, which is kind of I think the way that people get into Python. But the main selling point is that you can get a lot done really quickly with it. It's optimizing for developer or engineer time rather than execution speed. So it's been growing in popularity, and back in, I think, 2014, maybe 2013, a person called Damien George decided it would be interesting to try and make a version of Python that runs on microcontrollers. So they're tens of megahertz speed things with limited RAM and limited flash. And Damien is really smart and did an excellent job. The code itself has no CPython code in it, but it is a re-implementation of the same language, and it's pretty faithful to that. So MicroPython was kind of the origin of Python. Some other folks had actually tried to get Python on microcontrollers before, but MicroPython really did a really nice job with it. So that was 2013 or 2014, and then in 2016, in August, I had been going on Adafruit's show and tell and had started looking for work. I had been unemployed for the previous year, trying to do my own hardware startup, and learning how to do PCB layout and stuff like that. So I went and chatted with, or I had been showing that on show and tell. And then I said, hey, I'm looking for a job. I'm a software person. And they asked me to take a look at getting MicroPython working on some of the boards that they had already released, with the SAMD21 in particular. So it was a microcontroller that was very popular. They had used it a lot, and it was also on the Arduino Zero, but MicroPython didn't run on it. So they hired me to get MicroPython running on the SAMD21. And then as we saw that that was really a good idea, we just ran with it. I had a background at the time of using regular Python, so it was really kind of love at first sight. I hadn't heard of MicroPython before, but I'd used Python for, I don't know, 10 years before that or something, and really like knew the ins and outs and understood the power of Python. And it was like merging with this newfound love of microcontrollers that I had done from the previous year. So it was kind of the perfect thing, the perfect thing for me. And Adafruit's a great company, and so they did an original project to get MicroPython working on the SAMD21, and then like after that they just kind of like signed up and we went from there. So as we did that, there was a couple things that we knew. That we were calling it right when we started Adafruit MicroPython. We weren't the first people to have their kind of version of MicroPython, and you can see today that other people have their own versions as well. But at some point there was this, like I had been looking at what the hardware APIs are, and realized that they were just not strictly the same across all of the different microcontrollers that it supported. And I knew that if Adafruit was going to invest in MicroPython as a platform, we really had to have a very strictly identical platform to build across, to build a bunch more software on top of. So one of the core things with why we decided to kind of stay as our own version of MicroPython was that we needed a foundation that upstream kind of regular Damien's version of MicroPython didn't give us. And in order to make it clear for folks which version they were using, we renamed it to CircuitPython. So all of our code heritage is from the MicroPython project, and Damien's done an awesome job making Python be Python. But at some point we decided that CircuitPython would be a venue for us to move faster and kind of control our own destiny as well. So upstreaming, so getting our code back into mainstream MicroPython would have been a ton of work, and we wanted to be able to experiment kind of at our own pace. So that's how CircuitPython was born. I think what you'll find is that we're very focused on making software on microcontrollers really, really easy. So one thing that we do that MicroPython doesn't do is like we show up as a drive, which MicroPython does as well. But what we'll do is if you save the file, we'll automatically reload your code. And that just like shortens the amount of time and makes it simpler to have your code running as quick as possible. So yeah, we're very focused on that. Our philosophy with our design is that we don't expect you to read the data sheet beforehand. We expect you to read our docs and learn a little bit, but then be able to make things with very concise code. And we've just grown and grown. We support a bunch of platforms now, and have 260 plus libraries last I looked. So, those goals we had 4 years ago definitely panned out and gone the way that we had hoped.
That's awesome. So if you're used to programming in, let's say, C, let's say you're used to actually Arduino C, how about that? Mm-hmm. And you want to go and try CircuitPython, what are the things you have to be aware of? What are the changes, the big changes between the two?
I think the fundamental difference is kind of twofold. One, like the thing that runs your code is entirely self-contained on the device itself with CircuitPython. So it shows up as a drive, and you can edit a code.py file on it with whatever software you want. And then the entire mechanics to get that code executing is done on the microcontroller. So that means that there's no, Arduino IDE install up front. There's like, if you have a text editor, and your computer shows up as a USB drive, like it can host USB drives, then you have what you need on your computer side to be able to edit CircuitPython.
So if I plug in a Adafruit board that's CircuitPython compatible, because I'm sure not all of them can run it, correct?
Basically, all of the new microcontrollers that we sell do. It is a question of whether it has CircuitPython pre-installed or not. So there is a process. If it doesn't come pre-installed, all of the Adafruit boards, mostly, the ESPs are a little weird, but they come with a bootloader that also shows up as a mass storage device. And so what you could do is if you plug that in, most boards, it's a double tap of the reset button. You'll get a something boot drive. And then there's a file format invented by Microsoft called UF2 that you just drag and drop that over. And then CircuitPython will be installed. It'll copy that file over, it will restart, and you'll get a CircuitPy drive instead. And then you're off and running. So again, to do the CircuitPython like upfront install, you don't need extra software either.
And I'm sure there's guides on the Adafruit website on how to do this then.
Yeah, totally.
Okay.
Yeah. And
then you get this code.py file, and you can open that up and edit it in Notepad++, or if you're a savage, Notepad, and as long as your formatting is correct, it'll just run.
Right. Yep. And if your formatting isn't correct, the device also shows as a serial port. This is you can kind of think of this as similar as Arduino's IDE's serial monitor. So if you have something that you prefer, like Screen or Putty or Teraterm, you could use that. Or we do suggest using the program MU, simply because it makes accessing the serial easier. It will auto-detect where your board is and connect it up for you. But it's by no means a requirement. So if your code has an error in it, what will happen is that Python will tell you what line the error is on and what type of error it is.
Awesome. My fans have been basically berating me for a long time to just ditch C altogether, or Arduino C. It's not entirely C, I guess, and go to, it's basically C. Go to MicroPython. So what I did is I scoured the web, like I usually do when I do research. I scoured the web and I looked for, Arduino has a very good reference section on their website, arduino.cc/reference. And basically you look for loops, you can look for variable types and all these things, and it's all very well easily laid out, and that's how I write code. I constantly have that page open. I tried to do the same thing for MicroPython, but MicroPython, I could not find a good source to show me how to format my code. Now, I picked MicroPython simply because it's the thing I've heard of the most in my comment section. But does CircuitPython have something similar to the Arduino reference, but let's say like on Adafruit's site, or actually anywhere?
So I think this is something that, maybe people, we haven't fully realized it or haven't emphasized it, is that it really is Python. So when it comes to code structure, like if statements, for loops, that sort of thing, any Python reference will apply. The place that you start to get into the hardware specifics, where you need to like do I2C or SPI, both MicroPython and CircuitPython have a read the docs page that has just like the API level stuff. And there's a few simple examples in that, but there are not, like, for the languagey things, like how variables work and how you define a function. That's all kind of right now something we assume that like you can find for Python generally. It is, I think, on our radar in Adafruit to actually like do a kind of learn Python with CircuitPython sort of guide or series of guides. But at this moment, I don't think we have that.
Okay, so it's already helpful to know that any Python reference will get you started at the very least, because it's a little daunting when you don't really know the difference between Python, CircuitPython, and MicroPython,
right.
To not have that sort of, because I'm sure most C will work in the Arduino IDE, but having the full reference on Arduino's website is comforting, at least to someone who's not in the know like me. Like I told you before the interview, I usually smash my face on the keyboard, add a couple libraries, and get my code to work that way, right? So
I mean, I still do that.
you know,
kind of programming.
you're not the first programmer to tell me that all they do is they go find a GitHub repo that works for them and then fork off of that. It doesn't make sense to start from scratch sometimes, but yeah, it feels like cheating to the novice, that's for sure.
Yeah, interesting. I'm just looking at the Arduino reference, and I do see what you're saying of like they do talk about control structures and stuff like that.
Yeah, and
interesting.
Obviously, I'm not saying Adafruit is doing it wrong. I'm just saying this is sort of how a lot of people learned how to program, and especially a lot of my listeners, because if you're an expert in a topic and you're watching one of my videos about that topic, you're in the wrong spot. Like, this is not, it's not for you. Most of us do the, grab bits of code and smash them together type thing, at least in my world. So
maybe, it should be said that like on learn.adafruit.com, we have a ton of example projects for CircuitPython. But I think you're right in that we could be better about like, oh, you're coming to CircuitPython and you have no background in regular Python. Like that is definitely an underserved thing for us, I think.
Yeah. So maybe for the future, or you know what? I probably will end up doing like documenting my learning procedure, and then maybe at least the people who are subscribed to me can at least benefit from the way I learn, because I'm sure nothing in the way that I learn coding is going to be standard, right? Like I've had a lot of issues picking up coding for some reason. It's just the way it works doesn't work in my brain. I'm a very physical based person. I'm been an automotive mechanic for 15 years. I teach the automotive trade. The theoretical stuff works in my head, but mostly when I can reference it to something physical. And that's kind of why I started with Arduino, because I figured programming would be less painful if I can make an LED flash instead of making a timer count up. You know what I mean? Right.
Yeah, print hello world's not that interesting. Yeah, I think that's definitely something we subscribe to with CircuitPython. Is like we really do want the first thing you do to be involved with something physical.
Yeah, absolutely. And I do think Adafruit's boards are all very interesting. Like the Circuit Playground, I had a guest early on in the podcast who knew nothing about programming or microcontrollers. He just liked RC cars. And he ordered a Circuit Playground Express, I think it's called. It says Circuit Playground. And he used the built-in sensors to make a sort of like a tilt sensor for his RC car to see when he was about to fall off the edge. And he did it all with the guides and the stuff and the examples on the Adafruit website. And he went from 0 to hero in a single project, which is awesome that there's a place on the internet where you can go, where you can get compatible hardware, compatible software, all the examples, and just make something work, that's awesome to me.
Yeah, I think it's important to remember that like programming is really just a tool that you use to achieve something else. Like I think some people, particularly who want to have it as a career, they just think programming is the end all be all. But it's important to always remember, especially when you're doing like in a position where I am, where it's like, what am I going to work on tomorrow? Like I have to remember, like, what am I going to allow people to do that they can't do in the future, that they can't do now by doing this work?
That's actually a very interesting perspective from your end, because from my end, I would be the one going, using the tools, using the programming to make something. But since you work on CircuitPython and you're the lead of CircuitPython, you're the guy who has to design the tools that people will then use to make stuff. So you're making the stuff to make stuff.
Yeah, I've used the analogy that I'm like, I work at the lowest level, so I consider myself to be like the designer of the like bespoke Lego brick, right? Like I'm not going to be the person that like puts the big Lego thing together and tells you how to put all the pieces together to make a castle. But I'm the person that will figure out like, oh, we needed like a piece that is a French doors or whatever, right? Like I'm the person that says like, if we had this brick, we could do these sorts of like big projects with them. And so my job is to like take a look at what those bricks are and make them available and easy to use.
So speaking of that, Have you ever like fulfilled customer or user requests for new tools, different tools? Like, do you take info from the outside and build stuff to suit their needs?
Yeah, we're definitely every year we do this thing called, well, this year was CircuitPython 2021. And we kind of ask our community to say like, hey, like, what do you want to see CircuitPython do in the future? Some things that have come out of that. One big thing is actually sleeping to make battery life better. And that's something we did last year, at least for the ESP32S2. I think, we don't necessarily, we won't listen to you and just drop everything into it. Adafruit has priorities that we kind of impose, but we do want to hear what people want to do. And Adafruit show and tell is a good way of that as well, of us seeing what people are interested in doing with electronics.
I actually just recently got sent a M5 paper. It's part of the M5 stack type of microcontrollers. Do you know?
Right.
Do you know about this?
Yeah, I've seen it go by. I don't have one.
Yeah, so I've got one in my hands, and it apparently runs MicroPython. I'm not sure if it runs CircuitPython, but I'm sure it's an ESP chip, so as long as it's compatible, it should work. But it has a paper display, like a e-ink, e-paper display.
Right.
So when you say stuff like making the microcontroller sleep to save battery, a device like this is ideal for testing, sleep modes and seeing how long we can stretch the battery out for. So I'm pretty excited to work on that. So the thing that you're adding, sleep modes or working on sleep modes is very interesting to me, because that's probably where I'm going to start attacking as soon as I get the basics of Python down.
Right. So there's good news, bad news. The bad news is that I believe the M5 paper has an ESP32 in it, which is the older version of the chip, and it doesn't have native USB. And native USB is something that we require for CircuitPython, because it's the thing that allows us to show up as a USB drive. So we currently don't have ESP32 support. We have ESP32S2 support, which is the newer chip from them that does actually have native USB. The good news is that the MagTag is a device we released last fall, and it was part of the Ada box in December, but it's also an e-paper display, just like that is. And that was the reason that we spent time on sleep, is because the nice thing about e-paper displays is they can show the image without any power consumption. So basically what you do is you wake up, do any data fetches and refresh the screen, and then you go back to sleep to save power. So all those mechanics are there, but unfortunately right now the M5 paper is not supported.
Well, that's a shame. I can hear the sad trombones in the background.
I'll give a glimmer of hope. So one thing that I really want to do this year, and fair warning, I've wanted to do this for a few years, but because we're trying to make CircuitPython very accessible, I actually want to loosen the requirement for USB for boards that have Bluetooth on them, particularly BLE, because I want to enable people to program from their phones and tablets. So I think once I'm through this Raspberry Pi Pico stuff, I'm really hoping to carve out a month or 2 or 3 to really nail down how you can edit code from a phone. And that will open us up to boards where they don't have USB, but they do have Bluetooth, like the ESP32 and the Microbit V2 and the upcoming ESP32C3 as well. Will all kind of be enabled by loosening the requirement for USB in favor of BLE.
So that is extremely exciting to hear, because I've had a reoccurring guest on the podcast, another maker. If you haven't heard of him, I guess he's a software dev professionally. He owns his own company, but he does a little bit of everything. He's gone in overseas to teach programming and set up programming type courses in Africa. And
nice.
He was talking about the fact that these people don't often have computers, but they often have smartphones, and they don't often have internet, but they often have Facebook. because what happens is they buy their phone, and then Facebook, the internet usage through Facebook is free, but
Right.
any other data they have to pay for. So
Right.
they go onto Facebook groups to look for help on programming. But
Huh.
it would be awesome to be able to do the whole thing from a smartphone using Bluetooth. It has reverberations here in North America. I'm not trying to discount that, but it'll have huge implications in the third world for sure if you get that to work. So I don't know if that inspires you a little bit more, but that's the truth. Some people, they only have one device, and it's a smartphone.
Yep, totally. I mean, like even my nieces, like I see my nieces and they already have tablets, but they don't have laptops, right? Like it's really important to think about like what is the first computer that you actually own, and what is yours, and what you have like domain over. So I think you just look at the numbers of smartphones, and you shouldn't ignore it. I did a talk last February at Pi Cascades all about this. Is like, computers. The first experience that people growing up now have with computers is very different from a lot of our experiences with it.
Yeah.
And phones and tablets are the way it is.
Yeah, I completely agree too, because so basically this summer I built a program with another professor to teach people who are not mechanically inclined at all the very basics of what they need to go get hired in a shop. So the way it works here is you need to apprentice as a mechanic, but basically in order to apprentice you need a sponsor, and that sponsor is a business. So you need some sort of mechanical skills, like what tools are, how to use them, what a car looks like, and that kind of stuff to be employable in the first place. So yeah, a coworker and I built a program from scratch to do just that. And part of it is computer usage, because every garage here has a computer. We have to be able to access the information systems from the builders, and teaching some of these folks. These are regular folks. You couldn't pick them out of a crowd, but teaching them to use computers is difficult, especially if they come from abroad, because they don't have computers. The best, like some of the students, the best computers they've ever owned was a hand-me-down Chromebook, and you're trying to teach like Windows-based stuff on someone who's only ever used a Chromebook. It's completely different. It's very different.
Right.
So the more we can integrate smartphones into the regular sort of computer usage stuff, the better I feel, because they're already a necessity. So might as well do everything from them, right?
Yeah. Yeah, I think it's got some really interesting implications in terms of like how do you edit code as well. Like, 'cause editing code is such a mouse and keyboard task. I think there's going to be some really interesting evolution of how you edit code in the next 10 or 20 years as it moves to being phone-based and touchscreen based.
Are the Adafruit boards, do they have some sort of block type programming language that you can use, where you just put sort of objects on like a whiteboard and you link them with wires?
The block programming I've seen is not that way. That's kind of more like Node-RED style. The block programming that I'm aware of is like a number of boards of ours are supported by MakeCode, which is developed by Microsoft. So that's one option. And then there's also a version of EduBlocks that will work with CircuitPython. So if you just go to, I think, edublocks.org, or not sure, but it will generate CircuitPython code for you that will then run on anything that runs on CircuitPython.
Because I feel like that sort of programming lends itself better to a touch screen. Like click and drag instead of typing.
Totally. Yeah, that's kind of my working theory. I met the teenager who made an EduBlocks and at PyCon a year or 2 or 3 ago now. And I was working under this theory that like what you need for programming on a touchscreen is something that looks like text code, but you interact with like blocks. And so that's still my working theory. I've also found this other person, Katie Bell, who just did a LinuxConf Australia talk about her thoughts on how to edit code in non like text editor ways. And it's going to happen. It's going to be really interesting when it does. It's just a matter of when.
Yeah, the future, I think the future only looks brighter and brighter for programming as the accessibility increases. Like, it's ridiculous that you can go onto eBay, pick up a microcontroller for $1 and be programming, I guess 3 weeks later when you get it. But
right.
There's some nice microcontrollers that are, a couple tens of dollars. There are some really nice ones that are a couple dollars. You can get single board computers. It's impressive what's available today compared to what was available just 20 years ago, 30 years ago.
Yeah, and Limor Fried, who started Adafruit and runs Adafruit, she just did the Linux Conf Australia keynote, and she actually talks about that, like, really that evolution of including like how you would program microcontrollers and how that has evolved and unlocked more stuff. So it's a great talk if you want to see like really like what set up Arduino and where did Arduino go from there and that sort of stuff.
Awesome. Well, last week I had a guest on from Arduino, and he had a lot to say about the origins as well. So it'd be really interesting for the viewers to go check out that talk as well. So
I need to listen to that.
Yeah, so just for the listeners, we're recording this before Andrea's episode is live, so Scott has not heard it yet.
I don't feel bad then.
No.
I'm always curious what they're doing though, because like Arduino has really paved the way for making microcontrollers accessible.
I agree. I'm getting into sort of at the same time as I'm going. You'll have to correct me if I'm wrong here. MicroPython is a higher or lower language than C?
It's generally considered higher level.
Okay, higher level. So I'm going lower at the same time as I'm going higher because I want to learn how to program PIC microcontrollers, which is very like basically machine code. And at the same time, I'm going to be picking up Python, which is, higher level. So yeah, programming the PIC is scary compared to plugging in an Arduino because you need a programmer, and that programmer does all sorts of weird stuff. Like it has to pull one of the lines super high, like beyond what the voltage requirements for the PIC is usually. Right. And it has a certain timing and then it drops it. It's very nice that the Arduino board itself, and of course all the new age microcontroller boards, I should say, they all have USB implemented, but PIC never had that, right? You need a go-between, which is, it's different. It's not as accessible. I would much rather take a board, plug it into the USB, and like you said, editing a text file. When I learned about Arduino, that was over, like I would have been over enthused to learn about that. I haven't actually found out until very recently. So yeah. I think Arduino definitely paved the way, but like with CircuitPython in particular, we're really trying to push those boundaries even further to make it really easy. I've kind of harped on within Adafruit for a while now, like what happens in the very first 5 minutes that somebody gets one of these devices, and like how far can they get and what hurdles do they have in that first 5 minutes, and really trying to undo or get rid of any sort of hurdle that you get, particularly in that first 5 minutes. That's incredibly valid because I have some ESP32 boards here that I've tried 3 times to program and I can't get it to work. And there's tutorials on YouTube on how to program these specific boards because they have some sort of weirdness with them. They have like a line that you have to short to another pin, but with proper timing. It doesn't make sense for a consumer-facing device, which is what I'm glad that someone like Xeon and someone like Adafruit and and Arduino, the professional sellers, they all dealt with it. It's plug in and program, which is the way it should have been from the start.
Yeah, well, there's a lot of stuff that in hindsight you think we should have done that always, and it's it's a trick to pick out what those things are. I think mobile support, like the BLE workflow stuff I'm talking about, like once we have it, it's going to be one of those things of like, why didn't we have this before? Why did it take us 5 years to add this?
I think, yeah, I agree. But don't forget, also, BLE chips have only come down in price in the last, what, 5, 6 years, something like that?
That's true. And some of the early ones, like the NRF51, didn't really have a lot of RAM to be able to do a whole lot.
Yeah, we're a little bit of a prisoner to our own progress sometimes. Like the definitely the brains behind the operations have been thinking 20 years ahead, but just, we're 20 years behind on the technology needed to make it feasible, because getting something to work and something to be feasible is two different things.
Right. And particularly cost, right? Like I think it's, Adafruit does really well by making things that have been around a while accessible when they cost like a certain particular amount, like an achievable amount. And so it's interesting to start to look at technologies like HDMI in particular and figure out how you can make them more accessible, because like the cost has come down.
Wasn't HDMI some sort of isn't there a license fee for HDMI? I thought there was something like that
There
really
is.
Yeah, it was cost prohibitive for a lot of things to have HDMI.
Yeah, it's like per device cost for official HDMI. HDMI, the plug can carry non-HDMI signals over it. So sometimes you'll see people say like this does DVI, but it's over an HDMI cable. And that kind of skirts that issue.
I guess that makes sense. So what kind of education do you have in the domain to get working at Adafruit, for example?
Yeah, so my background is I started programming in 2002. When I was in high school, I learned PHP from a book. And then a year or two after that, I learned Python from just the web. And then I went to college at the University of Washington and did computer engineering there. So I did my first 2 electrical engineering courses there, plus a whole lot of software work. Out of university, I went to Google, and I worked at Google for almost 6 full years on the Google Maps team. So that was, and then I left 2015. So when I left in 2015, I was really into racing quadcopters. And one thing I wanted to do was design my own flight controller software. And at the time, and I still think now, like the STM32 line of microcontrollers was kind of the way that you did that. And there was open source software already that ran on those. And so when I designed my hardware, I learned all the PCB stuff and manufacturing, and actually did like a small production run with Macrofab and did all the hardware testing and fulfillment and stuff in that kind of year. And then I also got started on the software side, and I realized I really just liked the embedded side, and didn't really like the whole like convince people to buy my stuff and support them with it. So I was showing all my drone stuff on the Adafruit show and tell, and then once the opportunity came to work directly for Adafruit, it was definitely the better option for me.
So are you at liberty to say what the working conditions were like at Google? How was it working at Google?
Yeah, of course. I mean, the NDA for them covers like the specifics of what you're working on, but I was there from 2009. I interned in 2008. And I never worked in the Bay Area, so I didn't work at like Google headquarters. I always worked kind of in a remote office here in Seattle. And the company, like I loved working on Google Maps. I love maps. I loved working on something that like almost everyone knew about in the whole world. That was really exciting, and it was exciting to just see the scale that you were working at. In terms of like what it was like at the company, like I never worked super long hours. I think I was there 6 years. I worked one weekend early on. I got treated like they treat you incredibly well, and there's a whole lot of smart people there. So so I really matured as a software engineer there, and I learned a ton. But the company grew when I was there, and I was just like, I had these kind of crazy ideas about what I wanted to do with maps that were very different from what they were doing, and I decided that regardless of what I was working on there, it was going to be so iterative that I wasn't going to be too happy about it. So that's when I decided, like, when I joined Google, I told myself I'd only be there 3 to 5 years, and so it was almost 6, and I was like, I think it's time for me to take some time, and I ran the numbers and could take about a year to myself to do whatever I wanted, and that's what I did.
Have you ever pushed an update that bricked something down the line?
Yes.
Yes.
When I was at Google, I don't know. I don't think there was anything. I certainly witnessed a couple of things where like Gmail was down and stuff like that, kind of on the periphery. But a lot of the times, I was doing the server that renders the map. So if you remember back, it works differently now, but it would load like all the different tiled images on the map, and I was working on that server. And basically, if that server is having some problems, like there's another server that will still be working. So like there's some redundancy there that just causes you to not see the bad things. And when we roll out a new version, you don't switch like all at the same time. You say like, oh, I'm gonna just run this here for a little while and just make sure it's okay before I make everything that same version. So usually, like, if there's any issues, like, folks won't see it from the outside.
I think every programmer I've ever spoke to, they always say that there's no like right time or wrong time to write code, because all throughout your career you're going to make mistakes the whole way through. You're going to have to look up reference the whole way through, and I just felt like asking that question because there's a lot of people who believe that they can't program because a lot of people are way better at them. But
right.
I think what I want to push on my channel is that you don't need to be an expert, because you can make mistakes and the experts can make mistakes. I mean, everyone makes mistakes, and what you need to know is if it can be broken, it can be fixed. So I'm trying to give people a little bit more confidence in their abilities.
Yeah, and I think there is something to be said, like the impression I've gotten from Lamore, who's the founder of Adafruit, and she did a ton of Arduino, right? Like Adafruit really grew with providing libraries and stuff for Arduino. When she started doing CircuitPython, she, I think, really liked that the way that CircuitPython crashes is a lot friendlier. Like if you write Arduino and it causes like a hard fault, right? Like it's not easy, or it's tougher to recover from that. It's tougher to see what the problem is. Like your board stops working. Whereas in CircuitPython, most of the time there are ways to get like severely crashing, but most of the time what will happen is you'll just get what's called a stack trace, which is just like on the serial output, it'll say like, at this point in your code, this thing happened and we don't know what to do about it. But your code's still running. You can still like save the file again and it will rerun. Like there's nothing super fatal about those sorts of errors.
I think
it was really nice for her to do that.
Yeah, for sure. I think the biggest complaint I have on the Arduino IDE is that even people who aren't good enough at programming to get themselves into serious trouble, the Arduino IDE does not spit out a very clear reason why the code could not compile. Like sometimes it'll say variable not declared in this scope.
Right.
And it's like, okay, what do you mean? Because my variable is there. It's the right type. What do you mean it's not declared in this scope? What scope are you talking about, type thing? And so then you have to go post your code somewhere, and someone's like, oh, because you put it in the setup instead of before the setup. And it's like, well, that would have been really helpful. I mean, if a human with 2 eyes can look at it for 30 seconds and be like, you got this part wrong, why can't an IDE, which is meant for beginners, let's be honest, it's really designed for beginners, why can't it do that? So that
Right.
was my big complaint on the Arduino IDE, basically.
Yeah, and I don't know what version of GCC they're using under the hood, which is like the compiler that would be generating those errors to you. But the GCC folks have actually improved their error messages a lot, and they've really been pushed by LLVM and Clang, which is an alternative compiler. And when it kind of first came on the scene, it was known for how much better its error messages were. And the GCC folks have definitely upped their game for that as well.
I know I have been pushing off an update for quite a while, so I don't know, maybe it's better now, but I feel like sometimes the updates break my code, so I typically try to finish projects before I update my IDEs and stuff, so
Yeah.
maybe it's not the best procedure, but yeah.
That's definitely true. There's something to be said for like it works now with the versions I have, but I am also a firm believer in that software gets on the whole better over time. There's always new bugs, but there's on the whole it's always an improvement.
Yeah, I agree. And obviously it's people who think like me that are the reason that Windows now pushes updates whether or not you want them. So I can see both sides of the argument on that one.
Well, I think connected devices are particularly troublesome because of security. I think it's more true for a device that doesn't have any internet access, that you can really leave it like on whatever version it's running.
Yeah, when you find that one restaurant that still works on Windows XP or Windows 3.1.
Yeah.
For those kids listening, there were other versions before Windows 10. There were a lot of them.
Or I think so. My father-in-law is a mechanic, and I'm pretty sure shop computers are the sorts of things where they're not connected to the internet sometimes, and they have these old systems for storing work orders and all that sort of stuff.
Yeah, the old systems did. They have an internal system called Reynolds or ADP, two different companies, and they're really like text. Like they look like basically CLI. They look like command line because you can only type. You can't even type special characters most of the times, and they use an intranet. For those of you who don't know, it's like the internet but inside, only like within the company. Right. But these days, with all the manufacturer informations and stuff that you need to work on cars, they all have to be connected to the internet. So we still use systems like my work. We use Reynolds and Reynolds, which is like I think when you boot it up, it says like copyright 1986, and I don't think they've changed the GUI since then. But yeah, I mean, I know exactly what you're talking about. Can you talk a little bit about what sort of hardware stuff you were doing with quadcopters? You have piqued my interest there, and I did take a look on your website that's listed on GitHub, which is chickadee.tech, and I think the last update on the front page is from 2016. 2015, 2016. Yep,
that sounds right.
So what kind of stuff were you trying to do there in 2016, 2015?
Yeah, so I was doing a modular flight controller. So a flight controller is basically like a small square board that has an STM32 on it, either an F1 or an F4 or F7. And then you have communication protocols out to like the speed controllers and battery management and maybe a GPS or a buzzer. And at the time, and probably still, I don't follow it as much now, but like you would want different form factors, and of course you need an accelerometer and gyro to be able to actually fly. You can't fly without those. And so what I had this working theory of like, let me separate some of those components out in a stack form that allows you to like upgrade the microcontroller separately of some other stuff and potentially break out more UART lines for GPS than you could before with the like single board versions. It was the modular is really a bad idea generally because connectors are expensive and every board has one or in my case two connectors. And so like you just can't hit cost targets. I couldn't really hit cost targets to make it that worthwhile, and kind of at the same time I was doing these like modular, like ending up being very expensive sorts of systems, the industry or the hobby side went more to all-in-ones where like really they were trying to fit everything on a single board. So yeah, it taught me PCB layout and like how do I get like code on a fresh STM chip, and how do I solder and get my soldering skills like practice some. But really the hardware I don't think was that interesting. It just made me appreciate what Limor does for Adafruit, is really being cost conscious about like, if I make this thing, I can sell it for this amount and still have good margin, but also be accessible cost wise.
Yeah, if Adafruit didn't have any margin, they wouldn't be able to hire people like you to work on libraries to make their products actually worth buying, right?
Totally,
they would be.
totally,
I mean,
yeah.
the big difference between a genuine, like a board you get from Adafruit and a board you get from China, is the one you buy from Adafruit is going to support the development of new boards and the support for the current boards. You don't get that off a AliExpress seller.
Yep. Yeah. Yeah. I like to say, Adafruit is an open source hardware and software company. They put a lot of money into the software, particularly CircuitPython and all of the libraries that we have. So yeah, you might be able to find the hardware itself for less expensive, but the reality is that software is really important for anything with a microcontroller on it, and you should fund that software. And Adafruit does. So buying from Adafruit's a great way to do that.
I completely agree, because if you leave me to my own devices, I won't be able to program anything, right? So those libraries are a lifesaver. I can take a DHT11 or DHT12, for example, temperature sensor, and I literally just go into the Arduino libraries, pick up the library for it, write 2 lines of code, and boom, I have like something returning on I have serial data returning on the serial monitor. So those kinds of things make these boards accessible to people like me, and I'm sure a lot of my listeners.
Yeah, and it adds value to all the hardware that Adafruit sells too, because
Absolutely.
that there's example code and that people have tried it.
Yeah, now I'm going to have to go look for a board with USB support so I can try CircuitPython alongside with MicroPython. So do you have a recommendation for anybody getting started with microcontrollers and CircuitPython? Do you have a recommendation for the type of board they should buy?
Yeah, so I mean, if you're just getting into it and you don't have a lot of sensors and stuff already, I would recommend the Circuit Playground, Bluefruit in particular. So there's three Circuit Playgrounds. They're all round boards with LEDs and sensors on board, and that's really nice that you don't have to buy anything separate. And the Bluefruit is the latest version of it, and it has Bluetooth support, and it also generally just has more RAM than the Express does. So for CircuitPython, the Bluefruit is your best bet. I don't remember what it costs. It's like $20 or $30.
Yeah, it seems I am on the website now. It's like $25.
I was pretty much right.
Yeah, you pretty much circled it.
Yeah, the other thing, the new hotness right now is the new chip from the Raspberry Pi Foundation, or Raspberry Pi Trading, the hardware side. The Raspberry Pi Pico is the board, and they're selling it for $4. It also has a bunch of RAM, or a lot more RAM. So it's a very interesting chip, and we have support for it for CircuitPython. There's also MicroPython support along with the C SDK. Arduino has said that Arduino support is coming, but it's not out yet. But it's a really interesting chip. It doesn't, the Pico board only has an LED on it, so if you don't have sensors, I wouldn't recommend it. But if you have sensors that you want to work with, that could be an option as well.
Yeah, can I get actually your, whether it be as an enthusiast or as a software dev, can I get your opinion on the Raspberry Pi Pico? And basically, for those of you who don't know, it's not, you might be thinking of Raspberry Pi as a full system on a chip. This is more like a microcontroller development board than a whole system.
Totally. Yeah. Yeah. So my hot take is the chip itself, the RP2040, is really, really interesting and cool. I'm not a huge fan of the Pico board that it's on. because of a couple things. One, it doesn't have silkscreen labels on the top side, so it's hard to tell what pins you're looking at. It also doesn't have a reset button, so it's a bit the way that you get into the bootloader, which the bootloader is great. It's the drag and drop style USB device bootloader that we have in a lot of our stuff, except it's like burned into the chip, so you'll never be able to mess it up. You just hold the one button they do have, you hold that and plug it in. So anytime you want to load code onto it, it's a little bit of a pain. So the board itself is not spectacular. It's also $4, and it's like they made a bunch of them, so they're kind of available, although they probably sold most of them. So if you can only get that board, there's some hiccups, but it's not unusable. But the chip itself is really interesting. And earlier you were talking about wanting to learn assembly language on the PIC. And the one thing that I'm really, really interested in with the RP2040 in particular, which is the chip on the Pico, that is designed by Raspberry Pi, is they have these peripherals. So outside of the CPU, but on the same chip, they have a thing called the programmable I/O, and each of those has 4 state machines. And a state machine is a thing that says, I'll read this particular instruction and do something on it. And I think it's really interesting because that's what computers do, right? Computers are state machines. They are number machines. And I think that the RP2040 is kind of the first chip I can see where we can both have Python, but we can also allow you to do very limited like assembly language stuff for like a PIO state machine. Or the RP2040 is actually a dual core chip as well. So it has 2 Cortex M0s, which are like proper CPUs that are like in a ton of microcontrollers. But because there's 2, we could theoretically run CircuitPython on one, and then, some people want to run CircuitPython or MicroPython on the second one. But it's almost more interesting for me to like teach assembly for the PIO state machine first, because it's 9 instructions that are each pretty powerful, but that gets you into this mode of like, this is really a machine that's just doing some number manipulation. And then once you are comfortable with that and you want to like get the full power of a CPU, that second M0 core could be something that you actually would write assembly for as well. And you'd be able to like load the assembly and debug it all from Python potentially, which I think is
really interesting.
Yeah, I think that's actually, people have said like, I can't use the second core, and it's like, well, I'm kind of like waiting to see what people want to use the second core for before we just say like we can run Python on that, because there would be a lot of advantages. Python, one of the problems with Python is that it's not very real time. You don't actually know exactly how fast your code's going to run. That is the reason that they have programmable I/O state machines, is because they are like exact. You can know that this clock cycle is going to do this, the next clock cycle it will do that. Whereas as CPUs get more complicated, Cortex M0s are still very simple, but from then onwards it gets a lot more complex, and you can't necessarily know that like it does this and then that. Like the CPU in my desktop here is like doing all sorts of tricks to like do things out of order and things like that makes it really bad for real time and really hard to understand.
Yeah, you touched on this at the beginning of the podcast, but it's important to know that when you write something in Arduino C and hit compile and upload, it compiles it down to code that the Arduino can understand, and then that Arduino will run that code. But on Python, if I'm not mistaken, it gets interpreted as it goes. Like while it runs, it reads your code, then turns it into something that the microcontroller can act upon, and then it does that, and then it returns back. So there's like a back and forth where there's like an interpreter in between, right? That's why it's not real time. Yeah,
that's part of it. You can kind of think of, MicroPython or CircuitPython as like, there's actually like C code under the hood. So your text file of Python gets interpreted, so it gets parsed and compiled, but it gets compiled down to kind of what's called bytecode, which are instructions that the C code runs, not instructions that the CPU runs directly. And so if you look in MicroPython, and it's, we share this code with MicroPython and CircuitPython, is that there's a big for loop in C that says, if the bytecode I'm on is formatted like this is what I do. And then there's C code that runs to do that. So that's part of the reason that it's not real time. And then the other big thing that causes Python to not be real time is that it manages memory for you. So if you want to create a string, you can create a string and it will find a place in memory to put it. But there's this process called garbage collection that basically says, like, when you're done with something, how do we know we can place something else there in memory? And that process of garbage collection can happen at any point, which means that even though you're in a loop where you think you're only sleeping this amount of time, it might, in fact, do a garbage collection and delay you more than you thought you would be delayed.
Interesting.
So that's kind of the primary reason where I'm like, the philosophy with CircuitPython is to be the orchestrator between things that are running in real time. It's not meant that the Python code itself is real time.
And just for anybody listening, it is February 3rd today at the time of recording, and at least in Canada, I cannot get a PyPico anywhere. Yeah, they're actually, when the Pi Zero came out, which was the Pi board that excited me the most, because low cost for me is more important than processing power, because I can't even code something that requires any processing power, so it doesn't really matter.
Right.
But the Pi Zero was supposed to be a $5 microcontroller, but here in Canada, that's a lie. You could go pick it up at a store for the cheapest price. I think was about $20 Canadian, which is something like $15 American, something like that. But the Pi Pico, I'm looking at it, and it is $5.25 at a local retailer here. It's just out of stock. So I'm excited to actually be able to buy a product near its promised cost, but just have to wait for stock now.
Yep. Yeah, that's a function of the business model they have for it, whether like the first unit is subsidized or not.
Yeah, we'll see. We'll see if I end up getting my hands on one. I do have. Whenever I sort of cast a net, when I say I can't get something, it magically appears in my P.O. box. So maybe it'll magically appear, but who knows?
I have a feeling there's a lot of people with spare Picos now.
Yeah, you think so? You think they just got them from the hype and then they just want to send them off?
I suspect that because they're $4 a piece, that people probably bought more than they're actually going to use. So.
Well, I will definitely accept a free Pico. I feel a lot better accepting a $4 microcontroller than people who send me hundreds of dollars worth of stuff, which I appreciate. It just makes me feel bad,
Yeah, you'll pay more for shipping the Pico than the Pico itself, probably.
Oh, definitely, especially up here in Canada, since we don't subsidize our postal system, so everything is like brutally expensive to ship out. It's the reason why I was toying with making circuit boards, just fun little kits, but I can't ship them out for less than I think it was about, to the US it's about $12 Canadian for the cheapest available shipping. So when you sell a board that you have to have a little bit of margin in, you have to buy packing materials and whatever, it's going to end up like $20 when you can just go on AliExpress, get something not the same but a similar vein. You get 10 of them for that cost. Yep. So just not feasible.
Yeah, and you should definitely do more than just a small margin. Like, you have to be Raspberry Pi scale to handle small margins. Otherwise,
for sure.
You should really, I think this is a big a mistake I see a lot of makers make, is just not giving themselves enough margin to grow.
But I think the problem is, as makers, we have cost at the forefront of our brains at all times. I don't know about you, but for me, when I'm shopping for something, cost plays a huge factor, because I like to do a little bit of everything. So if I have to buy a little bit of everything, getting a quality product costs a lot of money. Like, for example, if you look at Xeon's Tiny Pico, it's quite expensive for an ESP32 board. Mind you, he put a lot of functionality into that board. And then when I got the board, I saw that not only did he put functionality, but he put a lot of like love and care into this board. I mean, to the point where he sands all the edges of the boards. They're all smooth to pick up. Everything is super clean, no solder residue, anything like that.
Yep.
So he was able to add value in a way that I'm not sure I would be able to add value to a product. I don't think I'm the type of person that would want to sand away the boards, right, to justify the cost. But Sion is the right type of crazy. I mean, when you're buying one of his products, you are seriously buying a product that's actually underpriced, I feel, for the amount of effort he puts into it. It's incredible.
Yep. I agree with that. I think he should charge more.
Yeah, I don't think he wants to, but he probably should.
Yep.
I mean, especially if he has to eat the cost of all those pick and place machines, right?
Yeah. Yeah. I mean, the benefit of making sure that you have a margin. And there's a post that Limor did ages ago about this. She says, like, you take the BOM cost and you multiply it by 3 or 4. And that's really what you should be selling something for. And I think what we'll find is that makers who don't do a margin that is that large will just never be able to grow because they won't be putting money in the bank to save and then hire a software person or fulfillment person or that sort of thing. So I think like in the long game, you can keep trying to break even, but really you need the margins to be able to grow your business. And it's tough.
Yeah, absolutely. Do you have any?
Yeah.
Oh, sorry. Go ahead.
I would just say it's tough, like especially when you're trying to compete with boards off Alibaba and things like that. I think it's really tough. I think brand is part of the answer to that. It's like you need, if you have a strong brand like Unexpected Maker, like Sion does, or Adafruit or 1Bit2, like that's really where you need to, invest in your value and assume that the brand will bring customers for a higher price product.
Yeah, and I guess the way Sion does it, he makes you feel as though the board is worth more than the components, than even the group of components. Like honestly, I'm gonna wait until the pandemic dies off a little bit because he sent me my board for free, which I'm very grateful for, but it took like 2 months to get here on express shipping. Because there's no more commercial flights, but I'm going to make an order on his website simply because like this is the best value board you can get if you're looking for a small ESP32. Like the thing's incredible.
Yep. And I should say Adafruit is a reseller for Unexpected Maker as well. So although there is some margin there, so some money will go to Adafruit and some will go to Unexpected Maker. It will get to you faster, likely, if you're getting it from New York rather than from Australia. And that money does go back to Unexpected Maker as well.
I would say, especially if you're an American, because you probably get your shipment in a couple of days, knowing the internal shipment in the US, although it is out of stock right now on Adafruit's website. Sad trombones.
Well, I think that's not sad for Unexpected Maker, though. I think
no, it's not.
He's been sending batches regular to Adafruit, and they've been selling out, so that's really good.
Yeah, and that just proves that there is a way to eke out a living making boards, but I'm not ready to go as extreme as Sion did to make these fantastic boards. I'm glad there are big companies making boards because I think as individuals, it's just like the amount of effort Sion goes through. If it wasn't for a labor of love, these things would just not be in production right now.
Yeah. It's tough. It's tough business. I mean, as somebody who chose not to do it, I can relate.
Do you have any personal passion projects or any projects that you're really proud of that have nothing to do with Adafruit?
Oh, that's a good question. I think, one of the challenges is that when I joined Adafruit, it really was taking my hobby and making it my business, or at least my business that was floundering that I was doing because I enjoy it. and now I'm getting paid for it. So I think, a lot of what I think about is CircuitPython and making it easier and more accessible. Outside of that, I play some video games, and the hardware side, the hardware design side, I do play around with a bit from time to time. One weird thing I'd like to do, but it's just like kind of hard to prioritize, is really I'd love to get CircuitPython running on regular Raspberry Pis, standalone, so that you could do, like, it would work like an old 8-bit computer kind of. I think that would be really neat, but it's just not a priority. So yeah, a lot of it's like revolves around CircuitPython. It just might be, devices or things that are just not quite as high a priority for CircuitPython or Adafruit.
So do you live that whimsical life that people dream of, where they just think of something to do as a hobby and end up getting paid for it? Is that kind of what you're doing for Adafruit?
Yeah, I think to a large degree that's the case. I wouldn't say it's whimsical. I think there is definitely a challenge to it. There's a challenge to having, what if you spent all week on your hobby, and what would you do as a hobby then? Video games are something that does fill that a bit for me, but at the end of the day, there's room for, like, a hobby has a place, and if that hobby becomes your business, it can be kind of tough.
What kind of video games are you playing?
Right now, my buddy and I are playing Astroneer. So generally like simulation building sorts of games.
Okay. I've heard of Astroneer. How do you like it?
I enjoy it. I picked it up right after it came out, and it was a bit rough, but still fun. And then it's been out like 3 years now, and my buddy hadn't played it. And generally when I find time to game, it's like with him or with somebody else. Also played some Age of Empires 2 Definitive Edition. Age of Empires 2 is just great. I
wasted many hours of my childhood playing the original for sure.
Well, the Definitive Edition is everything you remember as good as you remember it. But if you played the original now, you wouldn't think it's as good as you remembered it.
No, probably not.
So they've redone all the graphics, and you can even download like a higher res graphics pack for it and stuff. And it's really impressive. It scales up to like a nice monitor and things, but in the end, it's still Age of Empires 2.
Tell me, great. As a mechanic, when I'm sitting in traffic, I can look over at whatever car's in the at the red light next to me, and I can see problems with it. Like I automatically see what kind of tires they're running. I can see the condition of the brakes through the wheels. Does anything like that happen to you as a programmer when you're playing video games? Do you like sort of see the code behind it?
I don't think so with video games, really. I think video games are a very different type of programming than a lot of what I've done. So much about video games is graphics, and graphics has never been something that I really do. It did kind of remind me, though, like one of the reasons sometimes I don't like to do hobbies with CircuitPython is because I'm pretty likely to find a bug. And like I have this clock with the mag tag that I want to do, and like it still crashes from time to time, and that drives me nuts. But like it quickly takes me from like hobby project with CircuitPython back into like debugging that is really like more of my work. So yeah, I would say that I don't really see that with video games necessarily, but
yeah. You just touched on something. They say never buy a mechanic's car, and that's exactly why. Like when I come home, the last thing I want to do is work on my own thing for free even. And especially it's even worse because I see what's wrong with it. And if what's wrong with it is not a safety issue, I know it's not a safety issue. So I'm not motivated to fix it. So it's sort of like in the same vein of what you're talking about with...
Yeah, totally. Yeah, it's definitely the case. I mean, I get pleasure from seeing people pick up CircuitPython and realize how quick and easy it is to get going. Part of my beef with this project that I'm working on now is that it has to do with it's doing networking. And networking is just like orders of magnitude more complicated than most of what CircuitPython does, simply because it's communicating to something else. So, yeah. No, I didn't want to give the impression that CircuitPython doesn't work well, but
No, it's just, well,
I do run across the bugs.
when you're at that level, though, that's the thing. Because the thing that I think the listeners have to remember is that Scott can write himself into a corner, and you don't have that ability yet. So that's why he finds the bugs. Like you can maybe find bugs also, but the level of programming, if you're listening to this channel that you're doing, that's probably already been dealt with. So don't worry about it. Give it a try.
We hope there's no obvious bugs that most people would hit.
Yeah, because I think that's the thing, right? Like, if you think about climbing a ladder, everybody can climb the first couple of rungs of the ladder. So the first couple of rungs will be solid. It's just the super sports type people that make it up to the 100th or 200th rung. Those rungs are less tested. There's fewer people climbing all the way up there. Yep. I think that's the analogy I'm going with.
No, I think that's a good analogy, and I think that also ties into as a person who has a lot of influence. We call myself the lead of the project and kind of like guides where we go. It's important to be able to prioritize those first few rungs over the rungs at the very top. Even if the people who are at the very top and want you to fix those rungs are very loud, it's important to stay focused on the bottom rungs, and even in that case.
Yeah, and just as we speak, I'm probably going to be adding a circuit playground to my cart and order one today. So awesome. I'm going to, for all the listeners out there, I am going to hold Scott accountable if we find some bugs for a beginner at the very low rungs, and he'll hear about it. I have him on Discord now.
I mean, those are the bugs I want to hear about. So I hope there aren't any. I'm sure there are, and we'll get them fixed.
Yeah, I'm more messing with you. I'm sure it'll be just fine. I honestly think that I'll run into problems before I find, like with my coding, before I find an actual bug. I don't. But
those are what those problems are is interesting too. Like one thing that maybe people don't realize is, like, if you see an error message that doesn't make sense to you, like, we can change the error message. And so, like, even if it's not necessarily a bug, but you still struggle, it's really good to get that feedback, because you're not the only person struggling that way, guaranteed.
Yeah, for sure. And I hope if I do end up struggling, I hope that the videos created from it will at least help some people, because it's not always obvious to everyone to go like onto Adafruit's website and look at a guide. Sometimes, especially if you're used to being sort of independent, like I find myself having trouble figuring out when I should be asking for help and where I should be looking. So I think there's a lot of value in that also.
Yeah, so one good spot for help with CircuitPython is the Adafruit Discord server, which you can join by going to adafru.it/discord. And there's lots of folks there that are happy to help getting going.
I'll put the link in the show notes and in the description of this video if you're listening on YouTube. So I get to a certain portion of the podcast where I ask all my guests the same question. Have you listened to the podcast yet?
I listened to the start of one. I haven't listened to one all the way through, and I'm running out of time too. So I'm hoping this is like your wrap up.
Yeah, we're getting right to the end here. So
perfect.
So here's the question. The question goes: if we have a government agency that will fund you to build the business of your dreams, the idea is that the funds are unlimited, so you don't have to worry about profitability, but you do have to provide a service or a product. What would you do with that funding?
Ooh, that is such a good question. And that is such a question that I love to be able to think about. I think right now, CircuitPython is a lot of that. How would my work on CircuitPython change if it wasn't tied to Adafruit? is kind of the way that I could phrase that or think about it. And I think the BLE workflow stuff is one of those things that is like not directly tied to a product, but I think is very important. And I also think that the coding on a touchscreen is also very important, but also not super closely tied. So I think, I don't know. I also don't work that well completely on my own. So there's something to be said for having a little more give me feedback on where we're going. But yeah, I would say that like really bringing coding to phones is really what I would want to work on. Like there's just so many people with phones that and programming is such an important tool that everybody should have access to it, and that's what I would like to see.
Well, the question is purposefully open, so there is no wrong answer. So don't worry about trying to squirm yourself loose. That's quite a good answer. And
I guess I would also sorry, I had another idea. I would also love to see everybody have broadband access.
That's a big one.
Access. And that's a lot of capital investment to get fiber to everybody's house.
Yeah, that would. You know what? That would be a good use of government funds, if I do say so myself, since it's a government type question.
Yeah.
But yeah, that also, I feel like it also makes the listeners understand, like, basically, if the answer is something similar to what you're already doing, it makes the listeners understand that you're exactly where you want to or need to be to do what you're doing. So it's a great answer either way.
Yeah, I love thinking about that, and even if I can't do that thing tomorrow, I still try to work in that direction,
which is pretty awesome. So I can't wait to see what the future brings, because it seems like CircuitPython is in good hands between you and Adafruit. Just at the tail end here, tell the viewers where they can find you and what you recommend for them to go look up or do after this podcast if they're inspired by what you've been saying.
So the first thing is try CircuitPython. To do that, you can go to circuitpython.org, and then there's a downloads link, or you can just do circuitpython.org/downloads. That will bring you to a page to every board that we run on. So if you have any sort of microcontroller board, check that out. You can do a search at the top to see if any of the things that you already have are supported. If not, by default, the page is sorted by popularity. So like how many downloads of each board we get. So the ones at the top are the ones that the most people are using. So I would say try CircuitPython if you've never programmed before. If you have programmed before, I just encourage everybody to try it because I think we've raised the bar for what easy is. And then just some links outside of that. To support Adafruit, you can go to adafruit.com and purchase things from the store there. To find me, you can find me as TANNEWT on a lot of stuff. So on Twitter, I'm TanNewt. My website is tannewt.org. It's a little out of date, but that's my website. On GitHub, I'm TanNewt as well. So and Discord. So that's how you can find me. I'm always happy to hear from folks. The Adafruit Discord's a great resource as well. And the URL for that is adafru.it/discord.
And if you want to support Scott directly, he also is on GitHub, so you can sign up for a GitHub sponsorship. Most of my guests do not like to advertise themselves, so that's why I do it for you. There you go.
Thank you.
But
it's tricky.
Thank you so much for taking the time to come on to the podcast and share your perspective. And to the listeners, thank you guys so much for listening. I hope to catch you guys in the next one.